Now we are going to make this solenoid. You know that how the solenoid is made? It is made, suppose you have a coil like this, or a piece of cardboard also you can use, and on this coil there are turnings of copper wire. There are turnings of copper wire. This is called as solenoid. Now let's see that if we pass current through a solenoid, that then whether it behave as a magnet or not. So what we do is we attach battery to it. And we just switch on the current from this side, and we see that like the current is flowing like this, down, up, it's moving like this. So we see that whenever we connect a solenoid to a battery, it also behave as a magnet. It also behave as a magnet. It start behaving as a magnet, and obviously if it behave as a magnet, that means it will have a magnetic field, and if it has a magnetic field, so that means we can put the, we can show the magnetic lines, and we see that magnetic lines are just similar to the magnetic line produced by the bar magnet, as we did in the bar magnet like this. That lines we can just show by this figure. So the same thing can be the same kind of thing is seen here, this side also. So we see that the side where the current flows in anti-clockwise direction, the side where the current flows in anti-clockwise direction, that behave as a north pole, and the side where the current flows in clockwise direction, it behave as a south pole. So that means this is the north pole and this is the south pole. So we see that the magnetic lines, if we talk about, they are just running from again north to south like this. They can be actually shown like this. So we say that the magnetic lines produced are just similar to the magnetic lines produced by the bar magnet. So this is what is a solenoid. I think you got it. So solenoid is any coil having a copper wire turnings is called as a solenoid. So if you connect to a battery, just seeing that whether it behave as a magnet or not, we see that it truly behave as a magnet. It start attracting certain substances. So if we talk about its magnetic lines, it is just similar to the magnetic lines produced by the bar magnet. And if we focus on that word, what side is going to act as a north or what side is going to act as a south pole, so we see that the side where the current flows in anti-clockwise direction is going to act as north pole, and the other where the current flows in clockwise is going to act as a south pole. This is actually a clock rule. Now if you need to increase the strength of this solenoid or the characteristics of magnetic lines, if we talk about, then the strength of the magnetic field, in this case the strength of the magnetic field can be changed by, or you can say increased by, increasing number of turns of copper wire. If you put more number of turns, then more current, and more current means more magnetism. And likewise by increasing strength of current, more is the current, more strong is the magnetism. By decreasing gap between copper wires, So if you just decrease the gap, that means more number of turnings will be there. More number of turnings means the more current, and more current means the more magnetism. So this is how we can just alter the strength of the magnetic field by focusing on these things. Now if you want to make a electromagnet out of it, then what you need to do is just keep the soft iron core in the hollow coil, and then put the copper turnings. So we see that when we keep the soft iron core inside, suppose this is a soft iron core, this is the hollow coil, and there is a copper wire like this, and we arrange it like this. So we see that it could attract the substances toward itself, and it start behaving as an electromagnet. It becomes a electromagnet. And what is electromagnet? Obviously it start behaving as a magnet when electricity is passed through it, but as soon as you switch off the electricity, the magnetism is lost. So electromagnet is a substance which start behaving as a magnet, as long as current flows in it, But as soon we switch off the current, magnetism is lost. So this is what is called as electromagnet. Now if instead of soft iron core, if you keep a steel piece inside, and what you see that when you pass current, it again magnetizes, but it becomes a permanent magnet. That means it behaves as a magnet when you pass the current, but as soon as you switch off the current, the magnetism still remains in that. That is why it transforms into a permanent magnet. So if you want to demagnetize that permanent magnet, you just have to rough handle it, heat it, hammer it, throw it from top to down. That means more you will rough handle it, it will lose its magnetism more fast. That means if you need to demagnetize that, like if you want to demagnetize electromagnet, just switch off the current. But if you want to demagnetize permanent magnet, what you need to do is you need to rough handle it, heat it, hammer it, throw it, right, like this. So this is what is the permanent magnet. Now if we look for the the advantages or disadvantages of the electromagnet or the permanent magnet, we see that the strength of the magnetism of electromagnet is quite strong. The magnetism is quite strong. But if in case of permanent magnet, we see that strength is comparatively low. And moreover, in electromagnet we can change the polarities. We can change the polarities. How? By just changing the direction of current. But in permanent magnet, polarities, that means north and south pole, can't be changed. So once it is being made, one side is going to behave as that north pole and the other is going to behave as south pole. It is easy to demagnetize it. As I told you, just switch off the current, it will just demagnetize. But in order to demagnetize it, you need to rough handle it, as it is going to lose its magnetism very slowly. And how can you make it? We can make the electromagnet by putting the soft iron core in the coil and just wounding the copper wire, or directly you can wound the copper wire on the soft iron core. And in this case, what you need to do is you need to wound the copper wire on a steel piece, then the permanent magnet will be there. So this is what is the solenoid, this is what is an electromagnet, and this is what is a permanent magnet. See, difference between electromagnet and permanent magnet is very important. So just go through it. As I told you, I think I'll just repeat once more. It will behave as a magnet when current is switched on, but as you will switch off the current, magnetism is lost. It will behave as magnet when you switch on the current, but when you will switch off the current, still it is going to behave as a magnet. It is quite a strong magnet, it is comparatively weak magnet. Polarities can be changed by just reversing the direction of current. Polarities are fixed here. And even the strength can be changed. How? Just you can alter you can increase the current, you can increase the number of turns, you can decrease the gap. So by doing this thing, we can just alter the strength. But here the strength once formed is fixed, so it is going to remain that. And it is formed by wounding a copper wire on soft iron core, and it is formed by wounding the copper wire on a steel piece. So this is what is the difference between the electromagnet and the permanent magnet.